All right, so I'm excited to be here with Hannah Stepp and with Luke Nicol to talk about our robotics and engineering program. The robotics program has been going for quite some time. The engineering classes are more recent, but this is a really wonderful program. I'd love to hear how you all got involved. Hannah, why don't you start and tell us how you first got involved in this world down here under the gym?
Yes, my older brother and my dad both were very involved in robotics. And so as a freshman, I would tag along with them sometimes. And so I started my sophomore year. And I started as a very shy sophomore off in the corner, kind of figuring some stuff out because I didn't take the apprenticeship program that Trinity used to offer. And so I didn't really know what was going on.
And how does that apprenticeship program work, just real briefly?
Yeah, so it doesn't happen anymore, but some of the seniors for their capstone would teach freshmen about robotics, just the basic fundamentals of STEM, just so when they join robotics sophomore year, they would have more information. And so when I joined sophomore year, I didn't really know that much, but I also had kind of the background of my brother and dad, so I was definitely very interested in it. And for the first couple of weeks, I was scared about that because, going into robotics, you see a bunch of power tools, you see a bunch of high concept kind of things, and you're scared of oh, I don't know what's going on. So I kind of was scared about that, but then once we started getting into the actual competition, we watched the challenge video at the beginning of the year, and I was oh, now I'm tracking. I know what I can do to help, and I want to help to be able to have a robot by the end of the season that can do such and such. So I started working more with the team, asking, I think it was Heather Wright was the captain that year, kind of bonding with her over how I can help in robotics. And built off of that, the next year I was the captain, and then the year after that I was also captain. So that kind of growing up into that even though I started not really know what was going on, I ended up being a solid leader in robotics.
Yeah, that's great. And Luke, how about you? What's your story?
So I started the actual robotics my freshman year, and thinking back on it, it might have been better to have done the apprenticeship like Hannah suggested. A lot of the freshman year for me was learning the basics and stuff. Although I had a little bit of foundation, I think the apprenticeship would have helped a lot. But being thrown right into the robotics mix, I think like a trial by fire was a good way for me to learn to be beneficial to the team as a whole. So I've been doing robotics for a few years now, and every year I learn some new things.
Yeah, that's great. So can you explain to our listeners how this robotics challenge works? What it was, and maybe a little bit about the challenge this year. I think they can see the robotics field behind us here, and yeah.
Yeah, so it's split into 3 sections. There's autonomous, teleop, and endgame. So autonomous is where it's not remote controlled, it's all through programming. So the robot this year has to get off that center lander, drop down, roll back, drop off a little 3D printed idle, and then there's the concept of sampling. So basically you run into 3 things. There's 2 white wiffle balls and 1 gold cube, and these change position every single match. And the robot must be able to, through a camera, figure out where the gold cube is and knock it off without touching the other 2. So that's through, again, just programming. And then those all score points, and it's kind of what your robot can do in that time. That's 30 seconds. And then you want to talk about teleop?
Yes, so teleop is the manual control part. So instead of coding in directions, we code in buttons that tell the robot what to do on a regular game controller. And teleop's 2 minutes, and we try to do one main objective in this challenge. The main objective in this challenge is to get these wiffle balls and cubes into the lander behind us. And that has been a struggle for our team, to say the least.
A design challenge.
A design challenge,
Yeah,
yes.
yeah.
And then for the end game.
So end game, you try to lift back onto the center lander. And so it's obviously weight is a problem there. So a robot has to be under, I think it's 42 pounds?
42 pounds.
Somewhere in 40s, which isn't really a problem for us, but lifting is. So we've run through a couple of different lift designs just because no part of the robot can be touching the ground after that. And there's a very small hook on that center lander to hook onto. And so we've finalized it with kind of rack and pinion gears, to try to get like the most amount of torque and least amount of slip possible.
Yeah.
And we've been pretty successful with that. If you want to talk about hook idea.
Yeah, so we've gone through a lot of hook designs, like everything on the robot. It's a lot of revisions. Our first one was just a regular hook, and then after some serious thought process, we came up with the design of two plates that are two bars that once pushed up will open up downwards, and they slip back in place and they lock. So the cool thing about this hook is that thanks to our the design, we actually won an award last competition for this.
What do they call that award?
The
Innovative work.
Innovate.
Award.
Yeah. It's great. It's great.
So a
Yeah.
lot of teams would come up and be like, I don't understand how that would possibly hook onto something because it's kind of closed off. And we're like, well, and we kind of test out with our finger, like if you push down, it slides through, but if you push up, it's locked. And they're like,
Yeah.
oh, wait, I get that. Like, I understand that. And it's very cool to see in competition where everyone else has like an open hook here that they try to like attach and then lift from.
Right.
And ours just kind of slides on, locks,
Yeah.
pulls up. So.
I noticed in the competition on Saturday, because we had a tournament here this last Saturday with 24 teams, I think, and yeah, it was wild and crazy here. And I noticed a lot of the robots, some of them had trouble getting up off of their. You have to get all four wheels off, right?
Yeah.
And I think our robot and one of the ones I watched just got barely that fourth wheel off, and then we got points for that. And,
Yeah.
Yeah. So it's a real challenge. Yeah. The competition works like you. How many tournaments have you all had so far? Have you been part of as a team?
So we've participated in 2 tournaments
Okay.
so far, and they're scrimmages. And then since we've qualified, we will go on to another, the states.
Yeah, and that's the one that's a Saturday. And where is it? In Guilford County, I think, or
Greensboro.
Yes.
in Greensboro. Yeah, that's great. Usually, I think the tournament is at A&T, but at a high school this weekend. And then if you do well this weekend, then what's beyond that?
So 4 teams from the state tournament go to Worlds, which is in Texas in April. Normally there's super regionals, but they don't have that this year. I'm not quite sure why, but yeah. So we'll see.
Yeah. I think I've seen over the 10 or 12 years that we've had robotics teams that the competition, there are more teams out there now than there used to be, and the competition has gotten stiffer.
Yeah.
Is that fair to say?
Yeah.
Yeah.
A lot of the teams, they're like very young and they do very well, partially because we're noticing a lot of the parents are very active in that, which is discouraging to see because for our high school robotics, it's very much like student-led and student-oriented. And so, we're trying our best. We're doing high school level kind of things, and then we get to a competition and see some middle schoolers with a very much like adult-made robot. But it's still like, we don't want to change that. We would rather build it ourselves rather than have some parent build it for us. But that's,
Yeah.
I think, part of the reason the competition's gotten so
Yeah.
tough. Yeah.
But that's part of the magic of this program is that you're doing the learning.
Yeah.
You're active learners. You're having to face the challenges, and you're also you're learning through failure too, right? Yeah, I see you're
A lot of
nodding.
failure.
Yeah. So, can you give me an example of how you've learned through a failure?
Oh man, the arm. Actually, just the whole thing in general. The chassis was. This year we tried something new. We tried a different material, and since it was lighter, we had the weight limit thing.
Right.
So at first it failed because of the weight, and the pieces would bend and stuff. So
Yeah.
we had to switch to a chassis right before scrimmage, and the other one is the arm.
Just so many prototypes of the arm to pick up and put in the center lander. And the night before our last competition, the Trinity one, we realized that when we finally got the arm powered on the robot, fully extended up, it was still too short. And we're like, well, we can't use that. Like, there's no point in,
Right.
trying. But it's given us, like, obviously the idea of, oh, we need a longer arm to actually lift up and score things. But yeah, that's definitely been, we probably had 8 or 9 prototypes, honestly, with the arm. Still haven't gotten one that works, but we'll
Yeah.
hopefully get that one by states.
Right. That's great. Well, you're learning a lot of design thinking and design process through this, which is incredibly valuable.
Yeah.
learn by doing, prototyping, those kinds of things. Those are incredible life skills, and especially in the world of science and engineering, but also even in other parts of our lives too. There's a great book, I don't know if you've heard of it, called Designing Your Life, that is written by two Stanford they work at the D School at Stanford, and they have taken design principles and applied them to thinking about your career. And it's really fascinating because some of these ideas that you all are learning down here, they've applied to, okay, if you want to figure out what you're good at, well, make small bets, try something. If it doesn't work, then back up and try something else. And that prototyping model. So it's incredible the opportunities that you have to learn down here.
Yeah.
What about the engineering part of the space down here? Can you talk a little bit about this year we've expanded to do some other things down here besides the robotics? Can you all speak to that?
So a lot of the engineering, Hannah mentioned that we haven't had the robotics apprenticeship.
Right.
And so instead we've replaced it this year with the engineering. The engineering is more well-rounded. It goes through the same basic things like using tools and thinking like a designer or an engineer. But it's as I said, more well-rounded. It encompasses more things, different ideas, I guess, not just robotics.
And it's not just being part of that competition, but it might be designing something for a class or on your own.
Yes.
And what you have an idea, and I'm looking around. I'm seeing drill presses and bandsaws and all kinds of tools over here in this space, which we've created under the gym. And what about safety down here? How do we manage that? That's really important.
Safety is a big part. It's part of our grade also, our stewardsmanship grade. So over there on the door in front of us, we have safety glasses, and going past that section over there, it's required that you have safety glasses.
And also, like, we keep each other accountable. One of our teammates, Jarrett, is what do we call him?
Who knows?
Safety manager. I don't know. It's kind of a joke, but he'll just kind of call us out if we don't have safety glasses on. And most of the stuff we're doing is pretty safe. There's a very small chance of something flying towards you, but just to be extra careful, we definitely enforce that.
Yeah, that's great. I was down here the other day, and there are a couple of your classmates were working on different projects. They're trying to decide what to do, but one of them was a board to show who was certified to use which tools, and keep track of that. And that's another great thing that we do down here. So, Hannah, can you talk a little bit about your capstone? So the capstone is a senior project that every senior does, and yours is in this field, and would love for folks to hear about that.
Yeah, so kind of going back into my story when I first started. So when I first went into the robotics program, I didn't really know what was going on, and that kind of shook me at first. I didn't know if I belonged here. I didn't know if I had the same capabilities as everyone else because I didn't take apprenticeship and just everything. And so I started an engineering club for lower school girls. And especially just being a girl, there's not a lot of girls in robotics, and not a lot of girls as captains, especially. So I wanted to make a special effort to teach lower school girls how, the very fundamental things about STEM engineering, and also just build their confidence up of it's your idea, you can progress in that. It's been really fun. So I have 12 girls from grades 3 through 5th, and we kind of go in most Mondays and do different challenges. So the first challenge was to make a hex bug maze. So I split them into groups of 3, and it was great. They're very excited and very hilarious. And so it was just very hands-on. They have their own little engineering notebooks, just like we do in robotics. And so I kind of bring in what I'm doing in robotics is kind of you're doing the same kind of things here. Whether it be, trying to get a robot lifting on the lander or trying to get your hex bug over a little hill. Like, it's all kind of the same design process. And I've noticed that they're very like eager to share their ideas. Whereas me as a sophomore, even, I was like, well, I don't know if what I'm doing is right. But if you give them the kind of environment of like you're in a kindergarten classroom, surrounded by your friends, like you can give whatever ideas you want to. And that's been really exciting to see, because I want to encourage them to keep pursuing that, so when they come to high school, they can go into robotics as confident individuals ready to share their ideas.
Yeah, that's great. And Luke, I'd love to hear you tell a little bit about, we're watching this 3D printer working over here, and you put that together, right?
So every year, this is a relatively new thing, but the robotics asks that you do an in project, just to shore up what you've learned in the year about like designing and
There's
engineering.
a competition in sometime in March or
Yeah.
whenever, and
It's a
so
good-
then there's more of the year. Yeah.
It's a good filler. So my project last year was this 3D printer, and it seemed like a simple thing. It was highly rated. It wasn't too expensive, and I thought it would be I could knock it out quickly. That's why I chose it, basically.
Well, there's two of them over there, and
Yeah.
one of them looks like it sort of came out of the box. Is that
yeah,
right?
the bottom
Yeah.
the bottom one was
All put together,
put
but
together.
this one you had to put together, right?
Yeah, so the putting together part was the easy bit. I was able to do that fairly quickly in a week or so. Unfortunately, it didn't work at first, and it working is actually a recent development. So all of last year, like 2 or 3 months, and these first couple months, it's just been me trying to get it to work.
Wow.
It's a lot of failure. But eventually, we got
Lesson
it.
in persistence.
Exactly,
Yeah.
But yeah, we got it eventually. I had some help from my teammates, and I was able to knock it out. And so
Yeah.
now we use it for building parts for our robot, designing them, the
Yeah.
computers behind us, and
That's great.
There's rarely a time that nothing is being printed.
Right, yeah, it's
in
always
here.
working whenever I'm down here. So I want to grab one thing, I'll be right back. You gotta, did you all print these?
Yeah.
Yep.
Yeah, you gotta explain to everybody what, this looks like Bob Ross, the famous PBS painter, Bob Ross. What's the story here?
So last year in one of our long robotics practices, we were craving pizza. And so we were ordering pizza, and someone told me to put the name as Bob Ross. And so I did. And then we realized that it went to the front desk and not the robotics lab. And so poor Miss Dunlap was like, there's no Bob Ross here. Like, that, no. And so we were waiting for a pizza down in the lab, kind of tinkering with robots. And we're like, I bet it's because we put our name as Bob Ross. And so, of course, we face small reprimands of our creativity. But that's kind of carried into a joke of just Bob Ross.
Inside joke
Yes.
and, for the robotics team.
Yes.
And now this is your icon, is that what you call it? Or
Yeah,
is this
so
what you, yeah.
each team has a little idol that they need to place
Yeah.
in like a taped off section during the autonomous portion.
Yeah.
So that's ours, and it's great.
Yeah, that's great. This reminds me of a story from, I think, our 3rd grade. They study in their picture studies, they study the artist Giotto. And they were studying Giotto, and they'd been studying for weeks and weeks. And one of the students raised his hand and said, Giotto's great, but when are we going to get to study Bob Ross? So, yeah, he's famous around here. So this is great. Well, thanks for joining us. Thank you for talking with me about this. We have had a little noise going on upstairs. This is life down here under the gym. There's always people upstairs, PE running, lots of noise. It's been a great space, but we're also excited. In a month or so here on March the 23rd, we're going to have the head of school dinner and announce some exciting plans for the robotics and engineering going forward at Trinity. So I'm really excited. I won't scoop it yet, but we're very excited about what we're going to do in the future with this program. And you guys have been great leaders, so thanks for talking with me and thanks for your leadership.
thank you.
Non nobis.